On the other hand, I'm tempted to say that ChatGPT actually isn't capable of handling problems this complicated, and I'm not sure its scientific knowledge is exactly correct. And I'm not sure that the originality that's thought is really up to much, and I'm not sure that the designs that it's proposing really are the best way to go about constructing a space elevator. I'm not so sure that I wasn't actually correct to begin with the assumptions that I was making, and trying to pump liquid hydrogen and liquid oxygen up the structure to support to be burned in rocket engines, and to have ion propulsion in space to actually keep it stable above Earth. It would be extremely difficult. It would require a lot of propellant, and possibly it would require even things like fusion engines up there. But luckily, some engineering companies, one in the United Kingdom actually, are working on fusion propulsion currently. So that might provide an avenue in the future with which we can use a relatively small propellant weight to create a very large amount of thrust, and that could potentially greatly augment the fuel requirements for the rest of the structure if it were indeed to be pulling against the rest of the structure and keeping it somewhat taut, or perhaps not exactly taut but slightly loose. And it depends really. I think I'm not so certain like that ChatGPT, that mere ChatGPT is necessary or is capable of modelling this system, this design in its extremities to its fullest extent. I don't think. I think we need like more sophisticated software to be levelled at the problem in order to be able to properly encompass the full requirements of the project. So what I'm convinced of at the end of this process of research, of finally capitulating and using ChatGPT to try and figure it out, because it was proposing like going up to 120,000 feet with a huge tower supported, like I said, with probably aerostats filled with vacuum as opposed to helium lift balloons like I was originally proposing, but which is a good idea in fairness to ChatGPT, and jet engines as well. So keep that stage. But then what it was proposing was a launch vehicle going up a little bit, then connecting to a skyhook, then the skyhook connects to another skyhook, then another skyhook, and having this staged system of skyhooks getting through the mesosphere, which I don't know how those would be kept aloft in the mesosphere, and I don't think ChatGPT really addressed that problem either. And like that idea, I'm sorry to say, that's sort of like a glaring problem, isn't it, really, with the design ethos of ChatGPT? Like that's the sort of thing that that couldn't work. Not really. That would fall through the atmosphere and just collapse and burn up. And like what would be suspending it up in the mesosphere if each skyhook section was? I'll just go back to it real quick, just to sort of see what it wanted. Like optimize 2, 3, 4 stages of conventional material skyhooks and determine the minimum total rocket. No, that's not it. So it was saying that. Well, okay. What ChatGPT would actually build? Earth infrastructure, 120,000 foot aerostatic composite station. First stage vehicle, 3.5 kilometers a second, Delta V reusable suborbital vehicle. Orbital momentum stage, rather than our 100 kilometer / 7 kilometer per second monster, 100 kilometer tether at 1 to 1.5 kilometer velocity exchange. I'm not sure how this 100 kilometer tether that is rotating like this, I think, is what they're talking about, is what ChatGPT is talking about. I don't know how you prevent that from falling through the atmosphere without a considerable amount of propellant, because that problem just encounters the same problem that we're dealing with the vertical tower that I was sort of proposing, going up through the atmosphere, and burning propellant of some description or incorporating propellant of some description. And there are other ways also to keep it relatively straight, I think, in space as well. We can use solar sails, for example, though you need a very large area of solar sail in order to be able to do that. But that's just like one possibility that could be incorporated within the design, in addition to things like fusion engines. And it contradicts also a different idea that ChatGPT did come up with for using magnetoplasmodynamic thrusters, nuclear electro MPD magnetoplasmodynamic thrusters up in space as a good means of keeping the structure stable with a relatively small thrust to weight ratio for the propellant mode, with the propellant mode. So like, it's not entirely coming up with bad ideas, I don't think, but it's not reliable, is it? It's not enough. You know, you can't simply impute this huge engineering challenge into something like ChatGPT and expect to get like the correct answers. I don't think that the AI technology is quite there yet to be able to handle this sort of thing. I think what you need is like people who are experts at programming and shit, and real scientists and engineers working on it to really examine its feasibility. And yeah, I'm still very tempted by the notion that we can use propellants and conventional materials, which is the really crucial thing that I want to pursue, because I don't see us being able to develop carbon nanotubule technology really anytime very soon. So there's this table that it produced of how it assessed different feasibilities, how it ranked the feasibility of different approaches to this. So it said the conventional space elevator, the physics is sound, the materials are unavailable, and it's accessing a big red X on it, saying that's not possible. Earth connected 200 kilometer tether, problematic, technology extreme, not possible. Free orbital tether, sound, technology difficult. It gives a green light for that. Rotating skyhook, sound, difficult, green light. Skyhook using conventional fibers, sound, challenging but plausible, green light. Atmospheric reaching skyhook, sound in principle, extremely difficult. Orange light there for that. Skyhook plus 120,000 foot station, sound, very challenging. Green light / red light. Skyhook plus lightweight LEO docking station, sound, very challenging. Like none of this is going to be easy. That's the point. Of course it's not going to be easy. As I said, like the most difficult engineering project that's ever happened. Like, you know, harder than rocket science. I quite agree. Like orders of magnitude. Yeah, like orders of magnitude harder than building a fantastically big rocket or something. And like, it makes a good argument. Actually, maybe we should stick with rockets. Maybe, you know, for now anyway. When it comes to space, maybe rockets are what we've got to content ourselves with. But it's very interesting looking into this stuff, I have to say. Obviously, I'm so tempted to believe that a space elevator really is possible. But obviously what we want is we want a big space elevator capable of transporting a large quantity of cargo to and from space. That would be a dream come true, would it not? That would be the ultimate. That's what we all really want, I think. But demonstrating the technology, like how do you build a working prototype of this thing without? I don't want these skyhooks in it. I really don't. I think it's stupid. I think it's so liable to go wrong. I mean, they're talking about it moving at 1 to 1.5 kilometers a second. And like, how do you possibly prevent fuck up on that level? You've got a huge 100-kilometer structure rotating at 1 kilometer a second, going like that's a lot. That's a huge. That's very fast. How do you prevent it not moving just slightly and oscillating due to all sorts of things like solar radiation pressure and gravitational wave interference, even, or or orbital perturbations, or micrometeorites even impacting the thing, and like, how do you maintain it? How do you slow it down if you need to maintain it, if you need to repair it? The list goes on with how deeply challenging this project is, how deeply challenging these ideas are. It's high. It says very challenging. It says difficult. Like at best, it'll be difficult. At worst, it'll be extremely difficult. Well, at worst, it'll be like barely possible. Atmospheric reaching skyhook sounds in principle extremely difficult. Skyhook plus 120,000 foot station, which is what I think ChatGPT was proposing more like for integrating my idea in it. That's got a green light / orange light, very challenging. Yeah, well, I mean, yeah, it is very challenging. That's all you can really say about it at the moment, I think. But I don't know now what I'm going to exactly propose to the International Space Elevator Consortium. That's the other thing. I want to propose a single cable, more or less, going straight up to LEO, and being suspended in space by things like fusion propulsion in space. And that's what I would ultimately like to see happen. I've tried Gemini with this as well. I tried this issue of lowering the cable through the atmosphere. Gemini took issue with it. Said because it's horizontal velocity through the atmosphere, the cable would simply burn up to nothing. And I would sort of take issue with that. So if it's lowered by some sort of craft that's capable of steering the cable as it's being lowered, removing this rapid increase in momentum if the cable is being lowered from both ends. Got like a little rocket propelled craft going slowly down through the mesosphere, allowing the cable to drag behind it, and then that attaches to the 120,000 foot structure, and then the top end is attached to the stage built in space, and that's all being held up by fusion engines, or ultimately fusion engines, or magnetoplasmodynamic engines, or something of that nature. I like to think it might be possible. It's very sci-fi though, isn't it? But we want the sci-fi future, so we've got to try and build these things at least. Saying it's not worth looking into. Well, I don't believe in that necessarily. I don't believe it's not worth looking into. Anything's really worth looking into, but whether or not it produces results. Whether or not it produces something achievable. I mean, if it was going to be easy, then someone would have done it by now, wouldn't they? If it was as simple as dangling a fishing line from the International Space Station and having, because the space station moves at what, 9 to 11 kilometers per second. It goes around the Earth in about 88 minutes, slightly over an hour. So it's moving very quickly relative to the Earth at that stage in low Earth orbit, and it orbits out about 460 kilometers or so above Earth's surface. So really, the space elevator would want to be going up to that sort of height, I think. And probably not the 160 kilometer structure that I proposed, but I just wanted to make it 160 kilometers because I'm like, Jesus Christ, that alone, that would be more than sufficient. 36,000 kilometers out to geostationary orbit, I don't think that's possible, not anytime soon. But maybe we can build up to 160 kilometers. That was the logic there, using all these different propulsion systems to keep it stable and to remove compressive strain and etc. etc. I thought maybe that's possible. Yeah, maybe that seems like a good thing to look into. Clearly it's more difficult than I gave it credit for, but I have at least learned something as a result of all this. And I just don't like the skyhooks idea. I really want it to be a continuous structure, and I really want to ultimately get payloads to and from orbit get a payload into orbit once every 2 hours or so. That would be the dream, though, wouldn't it? But yeah, whether or not it's possible, I don't know. But actually, on a level like ChatGPT, even though it comes up with ideas that I don't think are very good, I think I'm at least capable of still of critical thinking and being able to spot ideas that are not very good also, compared to, like, it's a little bit arrogant, isn't it? They're a little bit arrogant, aren't they, all these chatbots? They always think they know best.